So this says lesson 3. Don't get stuck on that. That could change. The key thing is this is 2.12 or 2.12, and we are going to start doing calculations involving our equilibrium constant. So what we're going to do throughout the next few videos is we are going to be going through, I believe it's 5 types of equations involving your equilibrium constant. So when you're doing your homework, there's going to be a type 1 question, like we're going to do type 1 lesson, and you'll practice only type 1 questions. And then we'll do type 2 and type 3 and so on. And then my hope for you is once we finish all the different types, that you go and practice up jumbled questions, because it's all good when you're told what to do to know what to do, but as soon as you approach a question, you're like, what type is this? It's hard. So I have tried my hardest in these lessons to, write these little notes at the beginning to give you a hint on which type you're looking at. And so really pay attention to this. So what we're going to look at first is type 1. In type 1 questions, the question will ask you for you to calculate the equilibrium constant, and the question will give you a balanced chemical equation, or maybe you'll have to balance it, but the key thing that it's going to give you is equilibrium concentrations. It will say something like, at equilibrium, the concentrations are. When you're solving these, I've tried to write some steps. These are a little bit fluid, but the key thing is that you're going to figure out what is your Keq expression from your balanced equation. Step 2, if needed, you're going to calculate the concentration of each of your species at equilibrium. So that step 3, you can simply substitute the equilibrium concentrations into the expression and then solve for Keq. So these are your most straightforward type. So here we go. We have the reaction for the formation of ammonia, which is nitrogen plus hydrogen forms ammonia. We want to find the value of Keq if there are 3.18 moles of nitrogen, 3.625 moles of hydrogen, and 126.45 moles of ammonia in a 1.5 liter container, key wording, at equilibrium. So what's happening is they're giving you the equilibrium concentrations. Well, they're giving you the number of moles at equilibrium for each of your species. The first thing we're going to do is write Keq. So our equation for Keq is going to be the concentration of ammonia, which is our product, squared, divided by the concentration of nitrogen times the concentration of hydrogen cubed. Now be aware, right, if they're out to get you, make sure that this is a balanced equation. As soon as I see any coefficients, I know it's balanced. They're not going to write coefficients unless they're writing a balanced equation. So always double check that it's balanced. And then what we have to do is figure out if there's any solids or liquids or pure liquids. Again, that won't really happen here either. So then we can jump to writing our Keq, which we did. And then we want to put in our equilibrium concentrations. So to find our concentration, so concentration of ammonia, if you remember, concentration is moles over volume. So they've told us that we have ammonia, we have 126.45 moles of ammonia in the 1.5 liter container. So our concentration of ammonia is And again, we're not at a final calculation, so make sure that you're keeping all your sig figs, but that you keep track of the sig figs in the question if anything gets kind of crazy. So this is going to equal 84.3. Now again, we have a 1.5 liter container, but my calculator came out with 84.3, but maybe I'll keep track of the fact that this is just 4 sig figs. And the units for this now are moles per liter or molarity. Then we'll do the same thing with nitrogen. There are 3.18 moles in the 1.5 liter container, which gives me 2.12 moles per liter or molarity, and again that's going to be a 2 sig fig. And then let's do the concentration of hydrogen. 2.625 divided by the 1.5 is 1.75 molar. Okay, then we're going to put these concentrations into our equilibrium expression. So our concentration of ammonia yes, I said that right, I kept thinking I was saying ammonium, is 84.3. Our concentration of nitrogen is 2.12, and our concentration of hydrogen is 1.75 cubed. Okay, then we're going to plug this into our calculator. So we've got 84.3 squared. Now you have two choices. You can do divided by 2.12 and divided by 1.75 cubed, or you could divide by bracket 2.12 times 1.75 cubed. You choose. So do that now. I get 625.468 ... Now I'm going to keep track of my sig figs. So all of these were limited by the 1.5 liter container. So I'm going to round this to 2 sig figs, and that's going to make it an equilibrium of 630. Because it's an equilibrium constant, there are no units, and that would be my final answer. Okay, moving on. If at the same temperature, so I shouldn't say that, at the same temperature, but a different equilibrium position, the concentration of hydrogen is and ammonia is. What is the equilibrium concentration of nitrogen? So this wasn't put up here, but they could ask you to calculate for Keq, and they could ask you to calculate an unknown concentration. That is kind of an extension, or it's like a little bit of a wiggle with this. So what's going to happen is that because it's at the same temperature, my Keq is going to be the 625.468 ... So the rule is you should keep at least 4 decimal places. Even better, I'm going to store that value in my calculator to be used. So we've got this answer from our previous question, and we're going to say that Keq is equal to, nothing's changed, so it's ammonia, what was it, squared, divided by nitrogen and hydrogen cubed. This time, what we want to solve for is the concentration of nitrogen. So we're going to rearrange this equation to solve for nitrogen. Now, up to you if you've taken physics courses or lots of science courses. Some people will rearrange the literal formula, or some people just want to put their numbers in and then solve with numbers. I personally, with something like this, don't want to put numbers in till the end, because then there's a lot to keep track of. So what I'm going to think of is that this nitrogen's in the denominator, and I want to solve for it. So I'm going to multiply both sides by nitrogen. So then you end up with the nitrogen times the Keq is equal to the ammonia squared divided by the hydrogen cubed. And then I want to get nitrogen by itself. So I'm going to divide both sides by Keq. Now, when you divide by Keq, what actually just happens is that the Keq comes into the denominator. So you're going to have ammonia divided by hydrogen cubed and Keq. So I've rearranged the formula. What I like to think of, if you've done math for a really long time, is that when I want to do an equation like this, the nitrogen comes up and the Keq comes down, right? So I'm multiplying by nitrogen, I'm dividing by Keq. And now what I'm going to do is I'm going to plug into that formula. If all of that freaks you out, again, put just numbers into here. That's absolutely fine. But I'm going to plug it into nitrogen is going to equal the concentration of ammonia squared divided by the hydrogen concentration cubed times Keq. So into here, I'm going to put the concentration of ammonia at this new equilibrium is 0.10 squared. The concentration of hydrogen is 0.430 cubed. And then my Keq, I stored it as A. So I'm just going to type in A. Okay. So in my calculator, I'm going to type in 0.1 squared divided by 0.43 cubed, and then I'm going to hit divided by recall A. If you don't know what I'm talking about, feel free. Again, it's totally fine if you want to keep at least 4 decimal places, right? I always write down until I don't have to round. That's kind of my rule of thumb, so I keep at least 4 and then more if it makes me round, because rounding is where you get errors. So for me, I'm just going to type it in like this, and then my answer to 2 sig figs still is going to be 2.0 times 10 to the negative 4, and this time I have units because it's the concentration of ammonia. So it'd be 2.0 times 10 to the negative 4 molar. Awesome. Okay, so those are your type 1 questions, and let's do just another couple to practice. So I did those ones with you. I want you to pause the video and give these ones a go. Hopefully you pause the video and hopefully you're noticing that these ones are way easier than the one I did with you. So for this one, they're giving you the equilibrium concentrations and they're just asking you to solve for KEQ. So KEQ, I'm going to write my expression. It's going to be the PCl3 times the concentration of Cl2 divided by the concentration of PCl5. There isn't even any coefficients. So into this formula, I'm going to plug in the 0.40 times the 0.40 divided by the 0.32. So 0.4 times 0.4, or 0.4 squared, divided by 0.32 gives me, to 2 sig figs, 0.50. No units on your equilibrium constant. Okay, next question. For this one, at 200 degrees Celsius, the equilibrium constant for the reaction of nitrogen and hydrogen goes to ammonia is 625. If the hydrogen concentration is 0.430 and the nitrogen concentration is 0.100 at equilibrium, calculate the equilibrium concentration of ammonia. So again, I'm going to start with my equilibrium expression, which is going to be the ammonia squared divided by the nitrogen times the hydrogen. Okay, they are giving me the concentration of hydrogen at equilibrium. They're giving me the concentration of nitrogen at equilibrium. They are asking me to calculate the concentration of the ammonia. So personally, I like to rearrange my equation. So I'm going to say that the concentration of ammonia squared is going to equal KEQ times the concentration of nitrogen times the concentration of hydrogen cubed. If you're not sure what I did there, put the numbers in. But really what I did is I just multiplied both sides by the concentration of nitrogen and hydrogen. Right? Gone, 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 gone. And then it goes to the other side. So what you do to one side, you also do to the other. And since they would disappear on this side, you'd end up with this. So then I'm going to plug in, my equilibrium constant is 625. My concentration of nitrogen is 0.1. My concentration of hydrogen is 0.43 cubed. Awesome. Now, careful, that's not the end. That is my concentration of ammonia squared. So I've got 4.9691875. Okay, what we want is the concentration of ammonia. So I don't do this in my rearrangement, I do it in the end. The opposite of squaring is taking the square root, so that the concentration of ammonia is the square root of that answer, which is to 3 sig figs, going to be 2.23 molar. Awesome. Now you can go and give the type 1 questions a go.